So today I'm going to talk about notes on day 14, special cases. So there are two special cases of things that you can factor. And it makes it a little bit easier if you can kind of find the pattern. So the first one is called the difference of two squares. And what that means is if you have a parentheses that has, well, it doesn't have to have a parentheses, I guess. It could, it doesn't have to. So you have one square, like x squared, and then you have another squared, y squared, and you have the difference of those, which means that you've got subtraction in between. So an example of this would be like 25 minus x squared. 25 is a perfect square, right? 5 times 5 is 25, so that would be like 5 squared. X squared is a perfect squared, and then you've got a subtraction sign in between. Or it could be the other way. It could be x squared minus 25. Either way would be fine. You'll find that this is always going to follow a pattern. When you factor these, you're always going to have two parentheses. You're going to have x and y in each parentheses. So whatever the square root of the first term is, you'll put first. And whatever the square root of the second term is, you'll put second. And one parentheses will be a plus and one will be a minus. You could switch those. It could also be the first one could be minus and the second one would be plus, and it wouldn't matter. You could have exactly the same thing. So let's take a look at an example of one of these. Let me just write down the pattern here. If you have x squared minus y squared, you'll have x plus y and x minus y. So an example is x squared minus 9. So the first thing that you'll notice is you'll always have two terms when it's a difference of two squares. So once you have two terms, you ask yourself, is the first one a perfect square? Well, it's x squared, so yes. Is 9 a perfect square? Yes, because 3 times 3 is 9. And is there a subtraction sign in between? If the answer to all those questions is yes, you know you can factor it by putting two parentheses. You're going to take the square root of the first one. Well, x times x is x squared, so this would be x and x. You're going to take the square root of the second one. Well, 3 times 3 is 9. And you're going to make one a plus and one a minus. You'll see if you FOIL this out or double distribute, you will get back to this. Let's take a look at another example. So you have 4x squared minus 25. All right, 4 is a perfect square. X squared is a perfect square. 25 is a perfect square. And you have a subtraction sign in between. So now that you know that that follows the pattern, well, 2 times 2 is 4, so I can put a 2 there and a 2 there. X times x is x squared, so I'll put an x here and an x here. And 5 times 5 is 25, so I'll put a 5 here and a 5 here, and I'll make one a plus and one a minus. And now that is factored. And another example would be 25x squared minus 64. 25 is a perfect square. X squared is a perfect square. 64 is a perfect square. There's a subtraction sign. So the square root of 25x squared would be 5x. So I could put 5x here and 5x here. 8 times 8 is 64. You put an 8 here and an 8 here and make one plus and one minus. Now, please keep in mind, if this was a plus sign instead of a negative sign, then this won't work. So it would not be factorable. It absolutely has to be a subtraction sign in between. So that's one of your special patterns. The other one is called a perfect square trinomial. Perfect square trinomial. So now you're going to have three terms. All right. So now you're going to have three terms. So it will look something like this. You'll have x squared plus 2ax plus a squared. So basically what it's saying, if these last two are perfect squares, the middle term will be 2 times the square root of the last one times the square root of the first one. And then if you have that, it will always factor down to x plus a, which is the same thing as x plus a squared. You could write it either way. So an example of this would be x squared plus, we'll say minus 12x plus 36. Now, in this case, these don't always have to be plus. As you can see, this is a minus, and we'll take care of that in just a second. So let's check to see if this pattern works. Well, x squared is x squared. The last term is a perfect square because it's 36, so 6 times 6 is 36. So that's the perfect square of that. That's the perfect square of that. And the middle term, if I multiply these two together and then multiply it by 2, I'll get 12x. Well, that's close, but that's a minus and that's a plus. Well, remember, if this was a minus 6 times minus 6 would be 36, so that would work. So actually, my perfect square of 36 is actually going to be my minus 6. So now that I know that, this is going to factor into the square root of the first one, which is x, the last one, which will be negative 6, and then I'll square it. Let's try another one. X squared minus 10x plus 25. Well, this is a perfect square because if I square root it, I'll get x. This is a perfect square. I'll square root it, I'll get 5. If this is a subtraction sign here, this will always have to be a minus 5. This here is these two multiplied together times 2, so it works with the pattern. So that means this will be x minus 5 squared. So if this is a minus, this is a minus. If this is a plus, this would be a plus. Let's take a look at another one. 9x squared plus 30x plus 25. Well, this one here is a perfect square because 9 is a perfect square and x squared is a perfect square. So if I square root them, I'll get 3x. This one's a perfect square. 5 times 5 is 25. If I take these two and multiply them together, I'll get 15x. And if I multiply it by 2, I get my 30x. So that means, yes, the pattern works. So now I know that it's going to be this one and this one. So it'll be 3x and 5. If this is a plus, this will be a plus. And then I just have to square it. And then the last thing is that we can also use the zero product property rule on these. So for instance, if I have x squared minus 49 equals 0, now I have an equation, not just an expression, so I could solve this. So this is a perfect square, this is a perfect square, this is a subtraction sign, so this is the difference of a perfect square. So I know that's going to factor as x and x, 7 and 7. One will be a plus, one will be a minus. It's still an equation, so I'm going to set it equal to 0. And if you remember, the zero product property rule says that if I have a times b, it equals 0, then I know either a has to equal 0 or b has to equal 0. So I'm going to use the zero product property rule to solve this. So I know that x plus 7 has to equal 0, or x minus 7 has to equal 0. Well, if I solve each one of these separately, I know x could equal negative 7, or x could equal a positive 7. All right, if you have any questions, let me know.